There is no. Okay, so welcome to this roundtable session. Just before we start, very briefly, for Professor Bialek's public lecture, there will be, it's open to everyone, it's open to the public, not only from the school. So it would be great if we from the school could take like places more at the back, so like general public can take the ones on the front. That's first thing. And the second thing, just to give you a little bit more of a sense of how this, what's this roundtable about. So the idea is that we have our lecturers in the table, unless except for Stefano, who had to already leave, and Bill will join us later. And the idea is that we will open it to all of you to ask a lot of questions, as much as you want. We have a lot of time for questions until 7:30, so we will be asking questions for 4 hours. They will really appreciate. No, we have the slot that was allocated in the program. And you can ask questions either about how is research on the fields that they do, or questions maybe that you have that are related to more of one of the courses, I don't know, interactions between different topics. They will ask questions, by the way, about their courses to all of you. Sorry? No, I gave homework. But also general. And then opinion about also state of art and general questions about what's directions in the field, career development. If all of you that raise your hands about doing PhDs abroad and maybe have probably more questions than answers, everything you think could be answered, this is the moment to do it in a very relaxed atmosphere. So yeah, this being said, we open it for your questions. So who's gonna be the first? Perfect.
I have a question for you, and then for you, I'm going to be first with him because I am curious about being Hispanic and to study like in Europe and especially in our area. Yeah. I want to know like what was your trajectory and which was like the principal difficulties or the principal obstacles in your formation as a professional, as a scientist.
Yeah. Okay. Yeah. Thank you. It's a good question. My trajectory. Yeah. So again, I think I said it twice. I'm from Ecuador. Then I had the opportunity of doing a master's and a PhD in the Netherlands, and this really changed everything. I mean, if I got so the trajectory. So I did my bachelor's in Ecuador. I did computer engineering in Ecuador. Ecuador has like the French system where you study for 5 years, so that's a long time, and 2 years you do chemistry, physics, and which is good. I mean, because I still use those things. And then the last 3 years you specialize. So I went to study computer science. Then this is the one event that kind of changed my life in this sense, at least. I got a scholarship from the University of Utrecht. So the Dutch people were generous enough to give me a scholarship. And this is, I think, kind of unusual, but actually these things exist. This was 2003, so it's a while ago, but these things still exist, and I was the only foreigner student in that department. So I think they were happy to give me a scholarship, I suppose. And then from then on, I met my PhD supervisor, and of course, I was a good student. In fact, I was surprised that I went there to work hard, and then but people are very relaxed. They leave very early, and I was looking for things to do, so I found a lab to start doing research, and my first paper ever came from my master's work. So that sort of got things started. In terms of challenges, I would say the challenge is that coming from Ecuador, we don't really have a lot of scientific research, and this is being generous. There are some things in very specific areas, but there isn't much going on. So we, for example, I mean, you guys are different, I think you already know, but I had no idea what it means a scientific career, why do you do a PhD, and so on. I was just very naive. So that, I think, is a big difference. I'm very surprised I made it here because most students I see in the US, I mean, they really have the whole careers in mind. So I don't know. But anyway, in terms of potential advice, it's obviously harder I mean, coming from a place where we don't have the resources and the exposure. So, I mean, there are a lot of things. I mean, thinking about, for example, I don't know you guys are at different stages, but for example, if you want to do a PhD in the US, yeah, or in Europe, whatever, I mean, why would somebody offer you something? It's like, it's a big risk if I don't know you and you come from a place that I don't know anybody. So these things are big barriers. You can be super talented, the best student, the best mind, but there is a big sort of activation energy that if I know you, if you worked with me for a little while. So I think these opportunities, if they exist, to travel, to meet people, to show whatever you've done, those make a big difference. And so that to me is like, you know, at least one thing I can say that makes a difference. And then maybe just to connect to something I said in the morning, but I mean, in the big scheme of things, it's not the most important thing, but I remember, just to elaborate on that, when I went to the Netherlands, you know, people in the Netherlands have an agenda and they know where they're gonna be in 6 months. And so, I mean, it's a funny story. I tried to date this girl and I asked her, okay, can we go out? I said, yeah, sure, let me see. It was like in 6 months. And I was like, it's like every day.
Perhaps it was an excuse.
I don't know. It could be. It wasn't. It wasn't high priority, evidently. Anyway, but so people are super organized and they expect you to be organized. And I think for me it was a bit hard, I have to say, coming from South America, where indeed, I mean, I was oftentimes late for things, and you know, we are okay with these things. And there, the issue was that immediately you're like, of course, the South American, of course. And then like it's really hard to get over that. So that's not a big deal, but you know, it's something to keep in mind that you have to work against.
This is a question for all of you. It's about the biophysics field in general. And my question is like, do you think that we should use physics for explaining biology? Or we should use biology for maybe unravel new laws or physics? Because I think those are really different approaches. And people doing that is working different, have different minds. So yeah, I don't know. But this is a question for all of you because yeah, you have different information.
Am I being recorded or? I think it's a tough question, and I don't know if I'll be able to formulate a clear answer. So I'll try to say something that comes out of my mind. So on the first level, I mean, the first thing that comes into my mind is that we have these clear differences between disciplines, right? You go to university and you choose to study physics. And therefore you become a physicist, and therefore you think in a given way, you work on a given set of problems, you use these techniques. Sometimes then you perhaps you study bacteria, but still you are a physicist, right? And that's what characterizes you. Otherwise, you go to school, you study biology, you learn a lot of things, and that's the way you do things, and so on. I mean, of course, these like exist. We know differences. We think in different ways, and so on. But I think we should like sort of undo a little bit these barriers, right? In my experience, I don't know if that I really believe that, but let me say that. You should not really think of like, oh, I'm a physicist. What is the right approach for a physicist to work on a biological problem, right? Because this involves like some sort of, oh, well, I'm a physicist, so I have to belong to the group of physicists, right? I don't want to undo my physics background because, yes, I'm touching biology, so I have the risk of like sort of, becoming less of a physicist, right? And like if you are a biologist, sometimes you say, well, perhaps I really like math, but I don't know. I mean, I don't know if what I'm saying happens because I'm not a biologist. I have no idea what are the challenges, or perhaps I am, I don't know. But that's a good point. Yes, no, this is exactly the point. Yeah, but perhaps I don't know. I don't want to touch math because that's very hard. I will never able to understand it, which is, I think, like a huge I mean, I think everyone can understand, like, I don't know, the renormalization group. There is nothing, or the math behind it. I mean, there is nothing mysterious about it. It's just, I mean, it's not rocket science. It is, but it's like, you can understand. I know I made the joke, yes. So, no, yeah, I mean, what I'm saying is, I think that sometimes we think too much about, and I say that because I mean, coming from physics, I had this sort of, and I always worked like in biology, even if I study physics. And I always, now I don't feel it anymore, I don't care anymore, but once upon a time I was like, well, am I really a physicist, right? Or doing this, I mean, do I belong to the group, right? And I think that this is like, we should not think that way. I think that, and also by my, so this is like a first part of the answer. The second part is that in my experience, sometimes you communicate, I mean, the point is that this doesn't mean that people speak the same language or that is equally easy to collaborate or to talk to anyone, right? We try to, we have, let's say, an aesthetic, we give different, we have different aesthetic values to different questions, to different approaches, right? So if we are in front of a problem, we have a set of data, we tend to ask some question and not others, we tend to use some approaches and not others, we tend to look at the problems in different ways, right? And there is a huge diversity of ways to look at them, and this is like, I think there is no sort of ontological value in them, it's just aesthetic, right? I like to work in this way and I like to work in that way. In my experience, it's true, like discipline is somehow predictive of whether you are aligned in this aesthetic, in what you like to work on and how you like to work on, but this is not fully predictive. I mean, there is some signal, but there is a huge source of noise. So actually, I mean, there are many biologists that are like, are card-carrying biologists that I really like, I mean, to whom I can really relate, right? We sort of, even if we were different words, we speak this different dialects of the same language, right? And we understand each other, we understand why the approaches we use are important, why these questions are important, and so on. I don't know if I answered. I tried to, no? Okay, sorry.
Yeah, I wanted to say something about that. Presumably you're all in a school for community ecology, and you're not somewhere else because you have some interest in it. And I think the thing is, physics has a lot to offer biology. But if you come to biology, you can't qualify yourself by saying, I'm not a biologist, I'm asking this question, or I'm a physicist doing a model in biology. I think you have to commit to yourself to, there's been a culture of, it's like what Jacopo said, I'm going to say it a little bit more bluntly from the biologist side. There's always a feeling sometimes, and it's going away a bit, but that the physicists are telling the kind of the biologists how to do the modeling because they don't have any idea. And, you know, that is not true. Some of us are biologists by choice, not because we couldn't do it. And so I think it's a sort of, you have to commit to the field you've come to, and to respect that field. And so the way to, the one person I can say this about is Roger Nisbet. I don't know how many people know Roger Nisbet. How many people know Roger Nisbet? So he does this very, you know, he's a physicist by training, but then he was interested in biology. What he did was he went and took classes in biology. And he never refers to himself as a physicist ever, if he did. But so there's a certain amount of humility in him about these people letting him come into this other field and make a contribution. And he's a very, very smart person who could be the most obnoxious person on the planet, and he chooses not to be. So I think be aware that when you say, I'm a physicist, you know, what you say, well, I'm a physicist, but I'm doing a model in biology. No, you're interested in biology. Presumably, that's why you're doing a model in biology, right? So I think it's important. So what you can give the most of your skills and your expertise and your worldview to biology if you commit in that way. So, and also you'll get a great deal more out of it if you think of it like that. So, you know, there isn't, so you asked the question about how could a physicist sort of, you know, what sort of approach. What you do is you ask the question, well, what is the question? What's the biological question? And then how can I use my skills, my ideas to address it in a way that has not been addressed before? So I think that would be the thing.
If I can
I
briefly,
agree.
can I?
I
Sorry,
just
you wanna-
wanted to say that I agree.
If I can briefly comment on it, I actually have been here, but I'm not. I do not work on ecology. I'm an astrophysicist, astroparticle physicist. So I come from a field that didn't exist 20 years ago, and it was incepted from particle physics and astrophysics. One thing that I wanted to, so I'm originally from Italy, and I've been a professor here for 5 years, but I'm not anymore, so I can say things that piss people off because they can kick me out. So one thing that I realized, and it intertwines a little bit with the first question as well, is that in some countries, and specifically in Latin countries, where the power of hierarchy or the power of schools is very strong, people tend to identify a lot within columns. So what does my advisor do? I will do that. This is the specialty. I belong to this clan. This is obviously a very pushed statement, but you understand what I mean in softer terms. The fact that you are given the possibility to access a fresher world or a type of culture like the Anglo-Saxon one, where there is a little bit more intellectual freedom, or it's not so strong, the hierarchy can be not so strong, is one of the things that you can bring to what you do. So I would say the fact that you have the possibility now to be exposed to a different type of thinking is one of the things that it will also characterize your career as people from a specific place that want to make the best out of their life, or they want to do things and bring them here. So use this possibility of refreshing and not fall into old schemes at the best. This said, there is one important thing that I picked from a Nobel lecture that I had the privilege to attend in Stockholm, a chemistry Nobel lecture from Schechter that actually found out about the quasicrystals. And he said, wherever you do, be the expert on what you do. I think also the idea, I'm a biologist, I'm not a physicist, sometimes offer you justification, oh, but I can swipe over it because I'm not the expert. No, you're doing something, do it at your best. But then don't let the others define you, okay? So this is my personal advice.
I mean, one other, yeah, sorry, I'm Italian, No, I mean, following on what Priyanga said, I think that one important, it's like, get used to talk with people with different backgrounds. That is, I think, very important. So if you, now I'll use the word physicist because like we live in a world where like this is what we study, right? So if you are a physicist, you studied physics and you are interested in working in biology, don't talk only to physicists. That's the point. And if you are a biologist and you want to learn more quantitative approaches, because like there is not, because typically we think that, oh, physicists going into biologists, but there is no reason why biologists should not acquire like more quantitative skill. I think it's like talk to physicists, to mathematicians. So like to the person next door that is doing something else. I think this is like in general refreshing and useful and important. Yeah.
Just a few more things, not to extend this too long, but I think there's divisions, physics, biology, etc. I think these are social constructs. There is nature, and some of us want to understand it. And then it just so happens that we have different tools. In an ideal world, I think everybody should get the same education with all the quantitative skills, and then, of course, time is finite, so you specialize into some things and so on. Then, that being said, I do think that as a physicist, you have a great training, and then in particular, for example, that some biologists don't have. I do believe that. And in particular, for example, physics is a very old field compared to other areas. Biology is very new, so you may be more familiar, it's my impression, with how to interact between theory and experiments. There is a long tradition, what is a theory, and how Newton developed things, and you can tell all these stories. And so I think that's you're in an amazing position there, and from there you have a platform to do whatever you want. And if this requires you to do biology, do experiments, I'm sure you're familiar, there are a lot of physicists that end up doing experiments and know more biology than biologists, depending on what they do. So then those barriers are artificial, basically. I think that's...
That was actually my question. If you should, from the viewpoint of a physicist or a biologist, use just physics, like the current physics for explaining your experiments, or you should think like, maybe I can generate a new physics law, a new biophysics field, like think on that way. Not just use the physics laws you have so far, but then think on maybe in a new physics that can explain biology or life.
I don't think there is any physicist that looks for physics to find a new law. It emerges. You don't set up to do it. You do not set up your career to win a Nobel Prize or to write the ultimate model. You set up on either a specific question that Priyanga was calling mechanistic or something like how this thing work, or you want to give like a more generic question within a more generic scenario that to me is still mechanistic, but it's just a lot of clockwork together. But it's not, I want to find that. This said, if you have a physicist training, it's more that you might want to look in the direction of something more fundamental, and this also shows my prejudice as a physicist, but it's your preference, I guess, probably, no? I don't know.
No, now I understood the question. And sorry. No. And so just to repeat the question to myself, so I'm sure that what you said is, if I want to, I'm a physicist, I know physics, I'm interested in a biological problem. Should I use the physics I know, so like laws of thermodynamics for that problem, or I can develop something new, right? Okay, let's take the extreme of the first case. The extreme of the first case sometimes is that you try to push something that was formulated for matter that is non-living to living matter, right? So I don't think, or to the even extreme is like I use some methods and I force my, like a biological system to be described by that method. I mean, sometimes it works, but I don't think that is a general way to proceed. I think you should, this is what also Priyanga was saying. I mean, I think you should understand what's happening in the system, and I believe that sort of boiling down to the minimum, what is the job of a physicist? Is like, I mean, what a physicist believe on is that the nature is written in the language of mathematics, right? So you should transform the phenomena you see in the language of mathematics, right? And go back and forth between, like read the book of nature in the language of mathematics, right? And I think it's not easy, I mean, it's easy to say that. But what I mean is that you should not, I don't think you should limit yourself to the physics that it exists, right?
Let me pick on that. Sorry, and I know you have a question, but 1 second. So the Noam Chomsky, he was at MIT until recently, and he wrote something that the reason why physics was able to make so much progress is because they picked the simplest problems. Once it got too complicated, they passed it to the chemist. Once that got too complicated, they passed it to the biologist. Once it got too complicated, they passed it to the sociologist, and so on. So I say this because it sounded, maybe it's not what you meant, but it sounded like if you cannot do math, then it's not a problem for a physicist. I know you don't think like that, but there are people that think like that. And then maybe, you know, its problems are so complex, there is no math for this, and you need to resort to other things, you know. Maybe it's more about looking at data, statistics, simulations, I don't know.
No, it's not, no, I think we totally agree. I mean, yes. No, I think that, I mean, of course, like this, I mean, the point is that this way to approach the problem, which is like what we say physicists do, of course, like is not the only way to approach the problem, and in many cases is not the best way to approach the problem, right? So suppose that you had like many experiments where you had in vitro, you could have many solar systems, right? And you could measure whatever you want, right? There are things you can measure that makes perfectly sense, and you get Newton's law, right? You measure the orbits of the planets, and you measure their shape, you measure the speed, and you get Newton's law. Then you can measure other things. You can measure like what is the distribution of the mass of planets as a function of the distance from the star. Let's say that there is always a star and they are like the solar system, right? Those things are extremely complicated because they depend on initial condition, on contingency, and so on. Is the first problem more important than the second one? No. It's just a problem that it's easier to answer, and it's easier to have an answer that doesn't depend on initial condition, right? Now, there are problems where perhaps it doesn't, I mean, you can ask these questions, but there are many cases where this question doesn't bring you to anything, right? If you, I don't know, if you, yeah. And of course, for anything that then has practical applications, this is like, if you want to create like a, I don't know, to create a new vaccines, right? Yes, you can say, oh, let's simplify, let's assume that the cow is a sphere, but then, yeah.
The question is to everybody, and it's related to the discussion and to what Fabio said before. As a biophysicist or I don't know, the physician and biologist, physicist and biologist, how do you think is the career at the places where you work or where you come from? As like the places usually expect you to be a physicist or a biologist. So like the exams are made only for physicists or the exams are made only for biologists. At least where I'm close to. So yeah, that's it.
Oh, so the physicists who's successful to switch to biology and make a contribution can get positions in biology or ecology, evolution kinds of departments. And then you're assessed on the merits of the contribution you make to that field. In the US, yeah, very good point, yeah. But I believe that's not very different in Europe, I don't know. Because there are many people who've had a training in mathematics or physics having then switched to biology. But I cannot speak for other countries.
The other way around, I know is very hard, mainly because I think, for example, in physics, from what I hear from my colleagues in physics, but you guys should know better, that you're expected to teach any class in physics. And so if I was a biologist that I'm somehow very good in biophysics, and I go to a physics department, I cannot teach quantum whatever. So that's harder, yeah. You want to say something?
Well, I wanted to say something that it's sort of related. I mean, it's not like exactly on the question, but it's very related. That I mean, people talk a lot about interdisciplinarity, right? And we talk now about interdisciplinarity, the fact that all these disciplines are a social construct, and then perhaps there shouldn't be departments and so on. In reality, the world is not like this, and people have strong feelings about this social construct. So for instance, like if you apply for funding, for grants and so on, people typically say, well, we welcome interdisciplinary applications, but very often they don't, I mean, they don't really. Interdisciplinary means just that you're going to be evaluated by twice as many people, so you have like the probability that you are going to be evaluated is just the probability to the square. So it's like, it's much harder to get funding. So I think it's like, I mean, if you like this sort of trajectory of like working between disciplines and being serious in working between disciplines, I think there are also like, I mean, the world is getting ready for that, but it's like you are not in a world that is already ready for it, right? So there are difficulties in that.
Again, I was actually talking about this to Stefano this morning. So this is something Stefano told me just today. So you can do a lot of things, but if you want a permanent position, you just have to become famous for one. So
well, this is in the US.
In the US. In Europe, it's a completely different scenario. But if you're working at the interface, use 70% of your time to do something, be visible, enjoy it, find your career on that thing, and then use the rest of your time to do other things. That's totally fine. I mean, there is you have to, I think it's important to learn the difference between career building, having fun, actual research. These three things are not exactly the same thing. This is something that people have to keep in mind.
I think he wanted to follow up, sorry.
No, I agree, but sorry, I'll stop talking now. But no, but I think you should, I mean, it's important, is how the world is, and it's a complicated world to navigate. It's hard to get a position and to have someone that funds you to stay in your office or in your lab and doing what you like. So it's not easy. So it's important to know, like, how the world sees what you do, but I think you should not try to adapt too much to what you think the world expects from you. So if you think that a problem is like interesting, something that you can like work on in a reasonable amount of time, I think you should go after it and not try to think of what does the world like and adapt to it, because like you never know. So
I don't want to extend too much of the discussion, but personally, my graduation is not at either physics or biology. It's the middle term. So I cannot enter a place as a physicist or as a biologist. And do you think that changes your answers? Like, you know, because what Priyanga said was like to enter as a physicist who knows biology, who is starting to learn biology. But when you don't have the title, does it make a lot of difference? Like any of the titles?
So again, I can only speak for the United States. There are interdisciplinary programs now like that. Biomathematics departments, for example, have all kinds of people. So they're physicists by training, molecular biologists by training, statisticians, and so those kinds of departments where it's integrative. And there are also biophysics departments. I don't know much about them. The colleagues I've known, friends of mine who've been in straight mathematics departments, is actually they've taken the strategy that Fabio was saying, which is because the mathematicians are not impressed by you proving something about the Levin's model. You will not get tenure by doing those things, or even something much more sophisticated in biology. But what they do is 70% of the time you publish mathematics papers, but then eventually, and the rest of the time you work with colleagues you like. And eventually someone like that, Sebastian Schreiber, I think at least some of you have probably heard of him. He moved to UC Davis as an ecologist eventually, after having stayed for 20 years in a mathematics department, and sort of taking that strategy of, so you can, if you like both, it's not that hard I think, to do that. And I can't speak for the rest of Europe has a little bit of that too.
So sorry, I don't want to extend this a little bit, but as someone that was navigating last year the job market worldwide, and by worldwide I mean from Australia to Canada, it's very, very dependent on the country. So in the US, for instance, I have a PhD in physics and I was a postdoc in an ecology department. My impression in the US is that it is your research statement what defines your field. I applied from applied math to biology, physics, environmental engineer, I don't know, 5, 6 different types of departments. In other countries, it is not. In Australia, for instance, if you apply to a position in math, your job talk has to really have proof, theorem. If not, you are dead. Here in Brazil, it's pretty much the same. You really need to be a PhD in physics to go into a physics department. It's really, really depends on the country. It's very hard to make a general statement. My experience is that, as Fabio was saying, I don't know if it's Saxon countries or like more countries with shorter history, if you want. I don't know. Old countries like the old France, Spain, they are really, really stuck into what it is. The US, it's like way more flexible. Sorry? Well, I don't know if that helps, but it's super country dependent.
One thing to add probably is also that all this strategy and whatever, the then you're playing on extremely small numbers. So randomness is extremely important. You might end up in a completely different continent than you would want. It's deterministic at only a very small.
So more questions? Sorry.
Yeah, because in Brazil, the rule is that you have to have the degree in the area that you want to apply for jobs later, but it's kind of, a few places are different, right? So I got a job in a math department. It's the one title that I don't have, right? So I did a postdoc in ecology, PhD in physics, and I think it's the subject that I know the least, actually, of the three. But then, things are changing, right? So things are changing. So some places, yeah, it's a new university. You have ABC and so on. There are a few others, right? So you have to go and check for, do they ask for the title when they call for candidates or not? And then if you just know the stuff, then you don't need the title. This is things are moving in that direction very, very slowly. I guess.
So we have one more there.
I'm a little nervous, but I'll try my best to do this question. I was a little bit curious about, well, let me start again. doing science is hard, right? And studying science is kind of hard for students as well. So I was wondering if you have any strategies to reinforce your students, whether it's on lectures or as advisors. Yeah, so if you have any strategies to, to reinforce the knowledge and the capabilities of your students. And I'm curious, especially about Priyanga, because of the imposter syndrome in women students, especially. But yeah, the question is for all of you. Thanks.
It's a great question, and for personally speaking, I sort of came of age and did my work and got started at a time where even in the United States there are very few female theoretical ecologists and no female theoretical ecologists of color. So it was it's a very interesting experience. I've been in symposia, well, like I'm here too. Also, I've been the single female speaker, sometimes the one of two women in the room. So it's very, that was a decade or so ago, and things are rapidly changing. Now I see many more students, but there is certainly that attitude that, especially in biology students, that they cannot do mathematics. So that is difficult, and there is a certain certainly a gender difference in that, because the male students, even when they do not have the same ability, will have greater confidence and at trying something than female students, and it's a cultural thing. Even but what I do is I work very hard when I teach undergraduate classes to tell everyone this is something that could be learned by everyone, and it's not difficult. That the mathematics we use in biology is but a very small fraction of the field of mathematics, and this can be mastered. And one of the things I do say is, and it's very much a function of the North American education system, probably elsewhere as well, where you take calculus as an undergraduate, you take a 50-minute exam, and if you couldn't succeed in that exam, you did not get an A or anywhere near an A, and you think I'm dead. I cannot do mathematics. But when you do it, when you're solving a problem in biology or physics or engineering, you don't take a 50-minute exam. You sit down with a stack of paper and you work out what you have to do. So it's not a time constraint, and you can do so much more when that time constraint and the pressure of a grade is removed. So I use that sort of argument, and I also, because the University of California has a lot of minority students, a lot of Hispanic students, who tend not to be the wealthier students, or the ones coming from high schools with a lot of facilities or computational ability. And then you have to really make them understand you are not different from anyone. You can learn this as much, as easily, and as well as anyone else. Somebody who came with from a fancy high school, or if you're a graduate student, somebody who had an undergraduate from Harvard or Princeton, or someone who got an undergraduate from California State University, San Jose, or something like that. So, so what I do, I work very, very hard to motivate people, especially since if you teach pre-med students, so people who want to go to medicine and have no interest in ecology or evolution or physics or anything except to get a good GPA, you have to show them, like say, for example, AIDS modeling. So that's something that really resonates with people. Like, you show about this epidemic that arose and there was no way to control it, and how mathematical models helped us understand and predict something about the epidemic. You have to work very hard individually with the female students. Female students still tend to be even intimidated by female professors who are more quantitative. So, and male students are not, and they're much more likely to criticize you for their lack of success rather than themselves, whereas females tend to always be more introspective, think it's my failing, not the professor's failing. So it's a cultural shift. You have to work very hard. You have to speak to students individually. Especially, I recruited a large number of undergraduates as research students into my lab. So the work I showed you is from, well, he was a white male student, but I also have undergraduate students who are female and who do mathematical work. And then you have to really sit them down and say, this is, and then once they work it out, once they actually succeed, they're so amazed at what they can achieve. So it does take a lot of mentoring and patience and generosity on your part, but it can be done.
Just a very short note on what Priyanga just said about the ratio of the speakers, because it is a comment we get over and over different schools. It's not that we don't care about your comments. We are working and we are totally sensitive to that. Actually, this year, we almost made it, but we had a cancellation at the very end that broke this better balance. But for sure, for next year, something we're working on. Just for those of you that come year after year, and we are totally sensitive. It's not that we don't care. An excuse note. There was a question.
My question is a little bit hard to make. So sometimes it's hard to make science here in Brazil. So we like science, we're passionate, but only passion it's not enough sometimes. So I want to give you what kind of advice would you guys give to the students that are starting, that are just becoming scientists. So here in Brazil have some problems, cutting of funds and no money for research and everything else. So I'd like to hear about your path and if you face the same problems as you are facing nowadays. And what would you say to a student that is starting to stay motivated in doing science in a period that sometimes science sometimes means nothing for people, maybe. And you have to to rise and try to say and try to keep on, but sometimes it's very hard to go.
So let's see, some things you might not know. My two grandfathers were a butcher and a tailor. My mother didn't finish high school. So my path was in some ways very easy because I grew up in a place that at the time I was growing up, the public investment in education was very high. So you didn't need to come from a rich family to get a great education. This was California. I'm about to be 60, so you can calculate. So in the 1970s, it was great. I mean, the pinnacle of the University of California being supported by the state, so it was fantastic. I think one of the things that is hard is that your education is two things. One is its preparation for what you're going to do later, and the other is it's what you're doing now. And I think that as life gets longer, we should worry less about preparation for what you're doing later. Worry about what you're doing now. So you shouldn't go to graduate school. So my son has a good way of saying this. He got his PhD in philosophy. And he said, if you went to graduate school to get your PhD in philosophy because you thought you were going to be a philosophy professor, you were misinformed. This is not going to work. You go because that's the most interesting thing you can do with these few years of your life. So if you're, I mean, it's kind of cliche, right? Follow your passion. But I mean it much more seriously than that. That you're following your passion for now, right? There's this thing you could be doing, and you're really excited about it, and so you dive into it. Now, of the many things you could dive into, science, especially in its more mathematical and quantitative versions, has the feature that if you come out of it, you can probably find your way in the world because you have skills that other people are interested in. And in fact, that's more true the broader your scientific education. So the place where you might want to be a little critical is if you find yourself in an education, in a degree program that's somehow narrowing you too much. So you need an opportunity, you're young, you have a lot of energy, look around, find out all the interesting things that are happening in some reasonable radius around the place where you started. And the more, the deeper the view you have of those things, you will be better off. It's not deterministic, right? Nobody can say, if you get this degree and you publish this many papers and da-da-da-da-da, then you'll get this kind of job. Maybe once upon a time you could say that, although I don't actually think that's true. It's of course much more difficult. It's more difficult now worldwide, and there are fluctuations from country to country depending, on how the government decides to spend its money. But in terms of your education, maybe enjoy the fact that you're passionate. Don't say, well, I'm passionate about it, but I don't know that that's going to lead me anywhere. For 4 years, for 3 years, or 4 years, or 5 years, or wherever you are in the process, you have the opportunity to do the thing that you're passionate about. Most people in the world actually don't have that opportunity. So take that and make the most out of it, and then you see what happens. Most people in the world, so in the United States at least, most people change jobs in the real world, not in academia. Most people change jobs every 5 years. So if 5 years from now it turns out you have to go do something else, find the most interesting thing you can do 5 years from now, but don't worry about it now, because in fact, the world is changing rapidly enough that trying to figure out how what you're doing now is connected to the most interesting thing 5 years from now is very hard. Even if you continue as a scientist. It's not obvious that there's such an easy path from where you are now.
So next.
So another question, and it is related with science in general. Like, I feel like science is becoming a race for publishing. And like, people have a lot of you have to get some papers for getting a job, and then have a position, and then maybe you don't have time, at least as a student, for really thinking in a problem in science. So my question is like, how do you manage that? Like, you already have your labs, you have your students, so what would be your advice for not getting in that game of just publishing without really doing, I would say, real science and not just publishing?
I don't know if I can give you the best answer, but I do feel that problem very strongly. So that's why I took the microphone. Well, one statement is that I don't think you need to worry about this now. You are not there yet, I suppose. I mean, this is a stage where you're supposed to learn, have fun, enjoy. If you're thinking about, oh my God, I have to publish so many papers to get a job, I think you're wasting your time. You should be thinking about what's the most exciting question, more or less along the lines of what Bill said. Now, I feel like I should be asking that question to the more senior people in academia, because being in a tenure track program in the US in a very competitive school and so on, one feels the pressure of producing and having an impact and showing, and people have to know you and all these things. That being said, I in particular have been very lucky, and I did well with funding, so some of the pressures that my colleagues feel, I don't have them, and I'm in general quite happy, but for example, I have a big lab. I have 12 people in the lab. And there's a lot of responsibilities, a lot of letters to write, and also there is not much time for me to think and be alone in my office and think of new ideas. So it's something that I'm trying to learn how to deal with. And I don't have very good answers now. Probably the best answer is to shrink the lab, or maybe you have a better answer. But I don't think it's something very relevant at this career stage for you guys.
Or maybe, the question would be should we change that way of doing science, or?
I have an answer to that. So at quite a young age, I decided I wasn't going to compromise on my high standards, the high standards I'd set for myself. And I followed it throughout. I don't publish many papers, but the papers I publish are high quality and they get published in very good journals. I've managed to acquire a reputation by doing that, very fewer but higher quality papers. And I do, when my first job was at the University of Chicago with 24 papers, I was put up for advanced tenure, and then I decided to go to California anyway. But so in a place like that, which is probably even now the best ecology and evolution department in the world, but I was fortunate, as Otto said, in the sense that they cared about quality and not quantity. But many departments, including the one that I'm in now, counting papers is the thing that, so-and-so has so many, but the way it has worked is you gain recognition through the impact you make. And the impact can come from flooding the market with a lot of papers, perhaps. But you can also make an impact by writing a few very good papers that most people read. And so my advice to you is that do the best you can, take the time you want to think as deeply about the problem as you want, and then publish something better. Than it is much better to do one good paper a year, or rather than publishing 6 mediocre papers. And I also do the opposite of, I make it difficult for myself. I have a smaller lab, and all my students do their own thing. So I spend years helping them. There's a huge lag time between their work getting published, and so my getting credit for that. So I have to help them and do my own work. But it's the path I've chosen, and I like doing it that way because the students are never in my shadow, because they are known for what they do, not for being so-and-so student. It is very difficult to do, especially if you're a woman, you have children, you don't get credit for any of that. But I am not going to compromise on that. So that's been my resolution to that. And it works. So I'm a very good example that it works.
So, okay, we'll go there. There.
Some attention has been drawn to the problem that in academia we produce a lot of anxiety in people and burnout syndromes and in students and young professors. How do you deal with this in your personal life and also with students? How do you manage that?
So I don't know what it's like in other places, but I think in the US, so one part of the answer is that most universities have some on-campus health agency, which includes mental health services. And so part of the answer is knowing when the issues rise to the level where you need a professional, and it's not just, oh, I had it bad, you can survive, don't worry, right? There's a lot of that happens, and there's probably too much of it. Sometimes, it's like what we do, right? If you go and talk to the person who knows the most about the kind of science you're trying to do, in 10 minutes they can tell you you're doing the wrong thing. Right? You may decide not to agree with them, but they'll tell you something interesting in 10 minutes. So the same thing is true about mental health professionals. It doesn't mean if you go to a mental health professional that you're going to be in therapy for the rest of your life. It means you need to talk to somebody who has a professional view of this class of problems, just like we have professional views of the class of problems where we're expert. And one day of going to visit somebody, you can become much clearer about what your problems are. So that's part of the answer. The other part of the answer is, I think, maybe particularly in science, where we actively fight against the notion that what we're doing is about our personal feelings, right? It's supposed to be objective. Then a corollary of that is that we try to take ourselves as human beings out of the workplace. So I think, our colleagues in the humanities, they have their own issues about burnout and stress and so on. But at least in some fields, they understand that their human experience is actually relevant to what they do. Whereas we, in some sense, have declared that our human experience is irrelevant to what we do. And so it doesn't have any place in the laboratory. That's a mistake. Science is a human activity. It is an extraordinary thing that human beings, following their passions, following their curiosity, can figure things out that if other human beings independently follow their curiosity, they come to the same conclusion. That's really quite amazing, right? But it is human beings following their curiosity. And so we need to relate to one another as human beings, not as professionals. It's clear that our relationship with our colleagues is supposed to be somewhat different than our relationship with our friends and our family and so on, but actually in very important ways, right? One's supposed to be careful about some of these things. But they are human beings. And I think that in most places, that I've been, people are becoming more sensitized to this. And I think it's even more important when the people around you come from a broader range of backgrounds. So, you know, in the United States, it was typically true that you showed up at university and they had you live in a room with somebody else. Not 2 bedrooms, 1 room, 2 beds, right? And they just stuck you. There's some guy in an office did this. Well, you know, when institutions were very small and all of the people who went to them came from 3 preparatory schools, and they all came from the same socioeconomic class, and they all looked alike, and they all had the same kind of last name, this worked. Because the chances that you found yourself in a room with somebody who was somehow very much unlike you was very low. Already, by the time I was a student, this didn't work at all. So I didn't engage in this myself. I didn't live in a dormitory. But so, you know, when you walk into a laboratory and you look around, and literally people have come from all over the world, let alone the fact that maybe in the same country they've come from along very different paths. Now the issue of relating to all of them as human beings and encourage them to relate to one another as human beings becomes much more important. So I think that's part of the answer. Yeah.
I want to follow up on that to say that I desperately agree with this. Because, so I think, for me at least, but I think for most people, happiness comes from interactions with other humans, right? And like Bill said, I think I at least experienced this mentality, perhaps because, I don't know, I studied in Northern Europe. You know, we're scientists, we have to be serious, and this is a job, and blah, blah, blah. And then one day I met this guy in a conference. He became my best friend. He's like my brother. He's a great scientist in Israel. I visited him, I stayed at his house. I know his kids, we cook together, we talk about science, we write grants. This is one of the best things that have happened in my life. And it's because of the opportunities that you get through science of meeting so many different people, so many interesting people. Like you guys here, I mean, like the people from all over South America, a lot of interesting people. You can become friends, you can get connections, you can collaborate with people in Germany and everywhere. It's an incredible, incredible luxury. And so I think that's maybe the way to look at it. I mean, there's so many sources of happiness that could be found there, I think.
So there was, sure, I will use it.
Go for a run, watch some silly videos, read some really stupid books, unwind, drink a glass of wine. You all need it. That little time you think, oh my gosh, I'm going to finish that. Taking that time off will restore your sanity and make you do better work.
Just one thing that is related to that. I mean, don't think that the likelihood of like continuing doing science for the rest of your life is related to how many hours you put into that. It's not just a question of time. So if you feel you are like, I mean, of course you have to work and you have to make progress and so on, but also like you should not do too much of it. And you clearly know when you are at the edge of what you can really do. So it doesn't make sense to do more than that, I think, in any stage of your career. Now, of course, you have a lot of pressure, so it's understandable that you go very close to the edge. But as Priyanga was saying, take your time.
Yeah, I think the thing about, you know, how hard you work, I think there's this idea that science is a job, and so it should be regularly scheduled. Now, there's some kinds of things that we do in science, particularly in experiments, where it just has to be that way, because, you know, it takes that long to do the experiment, and something is going to happen in the experiment at this time, and you better be there to do something about it. But that's not true all the time, right? So sometimes when you're in the middle of something, you don't want to stop. And at that point, if you want to work all night because you're excited about it. But don't think that by working all night, you know, some number of days per year, you'll accomplish more just because you worked all night. It's possible to sit there and be working hard and accomplishing 0. And in fact, you know, in science, actually, a lot of the time we're accomplishing 0, right? The best we're doing is learning that, well, that doesn't work. And so for that, you know, that's not it's urgent to find out that that doesn't work, but if it takes an extra day because you needed some sleep, it'll be okay, right? It's not that urgent. When you're excited, in fact, it's important that you not waste your energy on, on things that aren't really that exciting, just out of some sense of duty that you're supposed to put in some number of hours, because then you won't have the energy when something really exciting happens and you want to work on it. Sorry. But then, yeah, right, that's right. Yeah, that's right. The other, I think that one thing that some students do wrong, and I mean, so I want to say this carefully, right? I don't want to accuse anybody in the room of doing anything, but it's a problem I've seen, is that the opposite of working too hard is, okay, let me be careful. So there's a class of students who's done very well, and they show up at the next place, and they think that because they did very well last time, they've been, somebody, the queen made with a sword on the shoulder or something, and so now they don't need to do anything else because they've arrived. I completely don't understand these people, because they're surrounded by people who are evidently very smart and all working very hard. So how can they possibly think that they don't need to work? Okay, that's a very small number of students, but it happens. Maybe if you live in a country where funding for science is bad, you're immune to this problem because you never get the idea that it's all going to happen for, okay. Maybe, in rich countries, people get spoiled more easily. The other one is the one which is more subtle, and that is where you're very critical about what problems you work on. And so you never quite engage and really dig into something. You're always wondering whether this is the right thing to be working on, and so you kind of go lightly. And it's true that the choice of problem is very important, but in many cases you can't tell whether this is the right choice until you dig in, to some degree. I mean, if the problem involves building an instrument, it's going to take you 3 years to build the instrument, and you're going to have to make measurements for 2 years, that's a different kind of choice. But for the kinds of things that most of us do, where digging in might, maybe you dig in for weeks to figure out if you should commit months, you do need to dig in. And you also need to be honest with yourself that sometimes you dig in and you figure out that wasn't the right thing to do. So there is a need to work, but there's also this, work in relation to what's actually happening, not to what you think is supposed to be happening.
So, more questions? We started very well.
I had a question more practical before, but continue with the more philosophical things or history things. Have you been in the situation of presenting your work to someone to, I don't know, make his next step that you considered was the most interesting, and how was that history for you? Did you have to meet someone, or how was the approach that you decided to have to, I don't know, continue with your careers or your things that consider more interesting, like you said?
I think I understand. Yes. So I say I'm not sure, but I think I understand, like how to transition between, for example, master's to PhD. How did I get my PhD?
Yes.
How did I enter a lab? Did I have to meet someone at a conference or something like that? Yeah.
Yeah, exactly.
Yeah, so well, I don't know. I can tell you maybe my particular story and then see, I don't know if we can generalize from that, but like I said, I had this scholarship to go to the Netherlands. That thing changed everything. I was a master's student, and then well, actually, maybe it's just a nice anecdote, but I was interested in this thing called artificial life, which is it was an area of like an kind of artificial intelligence back in the 70s, and then it now become very popular afterwards, but actually it's fascinating, people modeling living systems like ants, ant behavior and stuff like that. And I found this professor in Utrecht that happens to be a biology doing these things. He was a theoretical biologist. So she became my PhD advisor. I took her class. She apparently liked me enough, and then I stayed. And then when I transitioned to my postdoc, I mean, this is what most people do. Perhaps this is a practical advice. I don't know. You email people, and you say, hey, I like your work. Can I do something? But the thing is that, you know, professors get a lot of these emails. And then, I mean, I'm sure you have infinitely more experience than me, but I see these emails, and you get to see which ones you take more seriously than others. Some, I mean, you can already see that this has been sent to thousands of people generically. And then, but others, like, you start to see also, they at least...
Well, there's nothing in there that specifically refers to you.
Exactly. Exactly, dear professor, something, esteemed professor. Yeah. So when you see that, okay, this person has read the papers, knows what we're talking about, then at least this person deserves definitely an answer. And then, but then the issue is typically, this is something that I find people are not very well aware of, even in the US. The whole logistics of transitioning and getting the funding is pretty hard, and it takes time. So normally you start a year in advance because you have to apply for fellowships, you have to find the funding, and you have to find the best avenues, and so that's something that in my particular case, again, I owe everything to the Dutch taxpayers. They have this European countries like the Netherlands have these fellowships that for people that do a PhD in their country, regardless of nationality, you can qualify for these fellowships to go abroad. And so I got one of these, and I went to the US. But they have them in other countries in Europe. Yeah.
Nice.
Yeah, I think the logistic thing is very important. At least where I am, let's say, I don't know, well, different people in the room are in different stages of their career, but you know, in the US, applying for a PhD program, there's a deadline. And it's, you know, December 15th for September 1st of the next year. And in order to apply on December 15th, you have to have some stack of things that you can send them. So you have to be thinking about this, really, you really have to think a year in advance. And then the same thing happens at the level of postdocs. Almost all of the postdoctoral fellows that I work with are hired through a kind of collective thing where we pool all the money, and some of it supported by the university, some of it supported by grants, and anyhow. But then a whole bunch of us do it together, so we want to see all the candidates at once, which means we have to do it on a day, right? And that day is nearly a year before they would actually come. So the real problem of finishing one stage of your life after n years is that you need to be thinking about what you're going to do next at n-1. Right? That's the most important practical advice. The other one is you may be surprised by which part of the next step works. So there's a more intellectual question. And since we share the fact that we spent time in the Netherlands, although at different times, and I didn't know that until we met. I spent a year in the Netherlands as a postdoc, and the place where I went, there were 4 groups that I thought were doing something interesting, so I figured it'll all work out. I visited beforehand, and I talked to all 4 groups, and I said, well, you know, 3 out of 4 ain't bad. There was one group, I was sure these guys, this is not interesting. So I arrive, they give me share an office somewhere. I start talking to the guy who's in the next office. He's a PhD student in the group that I thought doesn't do anything interesting. Turns out he also didn't think that their ideas about what to do were so interesting. So it's 35 some odd years later, we still collaborate. The things that grew out of what we did to get, of the conversations we had then, are the things that made both of our scientific reputations. So the thing that I was sure was the thing that wasn't going to work, in a funny way, was the most important thing that I did while I was there that carried me for decades. So there's a practical part which is not complicated if you plan. And then there's the intellectual part, which is really complicated.
Yeah, something related is that I think that sometimes, like when, I don't know, people ask me, I mean, it doesn't happen many times, but people ask me about my trajectory, right? Is that a posteriori, it's very easy to like make a story that makes all perfectly sense. But if you try to go back to when that happened, it's like very often just random, like in that example, or like just you had to talk with someone and that someone was not present, so you went to the other room to that night's professor, and then wow, that was great, right? And you go working with that person. So it's, I mean, of course, like then when that opportunity presents, you have to go after it and recognize that it is important, but it almost never happened that you plan your life and it works exactly as you planned, right? It's driven by this stochastic event. And of course, like a posteriori, you can always make a perfect, meaningful story, but.
Actually, just to say one thing, because in my case, I can tell you, there's so much serendipity. It's ridiculous. Like, I mean, I planned the logistics. I think I did a good job, but everything else was, it's amazing. Like, for instance, like I tell you how I found my advisor. I didn't know she existed. I was Googling, at that time the search engine was Hotbot. I was looking in Hotbot, there's this area, and then this name started appearing again and again. Where is she? It's in the building next door. So and I took her class, and so on, and then PhD there. Then I was between going for a postdoc in 2 different labs. And I decided to go to the lab I went to where I started doing experiments. Otherwise, I wouldn't be doing experiments now. I went with all these ideas. I had a whole proposal of 15 pages that I wrote for my fellowship for that postdoc. And I started doing things. And when I was there, my advisor said, hey, you know, have you looked at this data? And I was like, wow, science paper 2 years later. So it's like everything is like, you know, I don't know. And you have to plan things, of course, you have to think. But it's just that you have to be open to getting grasping the opportunities when they appear, because they keep appearing and you cannot predict.
If I can comment on that, and since Bill also raised the fact of we're humans, no? So the human experience is extremely important. And that's my take about what I'm going to say. Other people might have other takes. When you're applying, my take is apply as widely as you can in places where you think you are at least interested. But the application process and imagining yourself in another place, how my life is going to change, generates an enormous amount of anxiety, depending on how you are. But it can generate a lot. So until you get an offer, that thing is just an envelope that you send. The moment you get an offer, you start fantasizing about yourself, how my life is going to be there, et cetera, et cetera, et cetera, and creating all sorts of anxieties and problems. But until you do it, just relax, because life is serendipitous. I ended up at Stanford because I went to a conference where I applied to, because I had an idea that I wanted to explore. So I applied to, and then I got there because they funded me, and then 9 hours jet lag, 2 change of planes, I needed to smoke a cigarette to nicotine to keep me up, and I ended up talking to the guy that was the only smoker in the conference and had just been moved at Stanford. So he said, oh, I have the money, why don't you come to my group? So it's completely serendipitous, really. I'm serious, it just happened so.
Jacopo?
Well, something that is related, I think, because you touched it with your smoker advisor. I think it's yeah. No, I think that one thing that sometimes is underrated is like, I mean, as we said, like science is like a human activity. Don't underrate the importance of the human relationship with the person you're gonna work with. So that's very, very important. Like now, there is something that Stefan always says, so I'm gonna repeat it. He says that the typical length of a PhD is, a PhD typically lasts longer than the average marriage in the US, right? So that means that, I mean, you're gonna spend a lot of time with that person, and I mean, sure, you want to have an advisor that does great science, that can write you many letters and so on, but you want also to have a personal affinity with that person, and I think that is super, super important. And I mean, you should also try to gauge that when you apply to a place, when you want to go to work somewhere. Not because like there are good humans and bad humans. It's just that it's a matter of like personal affinity, personal chemistry.
So it's also legal to ask what happened to your previous students.
it's legal to ask to previous students.
Previous students. I mean, you're going to somebody who's going to be your PhD advisor. How do you choose them? Well, I mean, how do you choose a university? Universities have reputations. It's based on something. It's a little complicated, maybe not terribly reliable, but it's okay. But you're going to work with this particular person, and you're entrusting several years of your life to them. Well, other people have also done this. How did it work out for them? And if the outcomes are consistently things that you wouldn't like, doesn't mean that they weren't good outcomes for those people. But if they're different than what you're looking for, then this probably isn't the place for you. On the other hand, if you look at this and you think, wow, I wish I could grow up to be like one of those people, then maybe this is the place for you. Not that complicated. But you need data, right?
So we have a question here.
Oh, well, as a theoretical physicist, there's a joke that I used to say, well, not a good joke, but that when you're doing theories, 10% of the time is composed by an excitation, a really strong excitation, and a huge amount of creativity, but the other rest of the time is composed by deep depression. And once I was telling this joke to an experimentalist, and he answered me that, oh, for experimentalists, this also happens. So my question is, what can we do in this 90% of the time in order to make it not so depressive and more productive or something else?
One of my very distinguished senior colleagues said, you must celebrate small victories, because otherwise, in general, it's you against nature and you lose. So, small victories, you celebrate them. And you know when you did something, even if it's a small thing. Even if it's figuring out that that's not the right thing to do. That also can be celebrated.
More questions?
I have the question for you, Professor. It's because I have like the notion of ecology, empirical ecology and theoretical ecology are very separated. And somehow like the empiricists look like subestimate the theoretical ecology. But you do, by your presentations, you do both, empirical and theoretical. How do you achieve that?
So more generally speaking, it used to be much more of a dichotomy, say 20, 30 years ago, because most biologists were experimentalists and you did have very few people in biology doing theory. The people who did do that, people like Robert MacArthur, were people who were doing physics but were bird watching in their spare time and were really curious about why there were so many bird species in different parts of the tree and things like that. It has become a whole lot more integrative since then. It is very difficult to manage both. You take a risk. When I first got my job at Chicago, I'd already done this. I'd already published some theory papers that were unrelated to my fieldwork. And then and I asked Andy Dobson, who's at Princeton, and I said, how do you manage this? He said, here's the thing, data take a long time. So while you're collecting the data, you write your theory papers. So what I ended up doing was a slightly different thing from most people, and I myself hadn't appreciated it until a referee pointed out, look, she has 2 independent programs. I did a theoretical research program that was completely independent of my fieldwork, which itself had a theoretical component. So the theory could proceed while I was getting the data, just as Andy had said. But I think for myself, it's very difficult to do one or the other because I know that as a theorist, I wouldn't do certain types of experiments because I know that would not be consistent with your expectations from the theory. And being a biologist makes me a much better theoretician because I know not to make the kinds of assumptions that are biologically unrealistic. So I think it's okay. So as a child, I was very talented at mathematics, and so, but I chose the biology stream. I'm from Sri Lanka, which is a very British style. Even now, I think British style education, where if you did biology, you just got channeled into biology at an early age, and didn't get to take the sort of the high-powered mathematics courses that the students who chose to go to physical sciences did. So there was this very big separation, which has changed now. So what I did was when I went to graduate school, I went and took all those classes. And that made it possible to really kind of join my sort of, those two talents. And ultimately, I think I chose to be a biologist because I am curious about, there are so many interesting things that I want to solve. So, and then many of them require some sort of mathematical underpinning to really sort of, to make sense of.
Some more questions? Yes.
So I was wondering here, you've been doing a very good work trying to talk this in between languages, between research areas. And this is a very good thing in this small scale that we're trying to build this interdisciplinary thing. But when we're talking about biology, sometimes we are also trying to reach at some point some applied application, going a little bit outside the academia as well. So what I've been wondering here, if there is any sort of broader scale communication skill that you're trying to acquire. And if you approach some society communication thing somehow, trying to speak this language that not many people that are outside science can do. Yeah. Should I repeat? Rephrase it, maybe?
No, I think I understood. It's just a difficult.
Yeah, it's because Brazil's going on this very pressing thing against science, and what we've been doing for the past months is trying to speak a little bit our grandmother's language and try to explain what we work with so they can understand that science is kind of appealing for everybody, not only us students and professors, really.
Yeah, I mean, I don't know, maybe in the US, I feel like there's a lot of emphasis on outreach, which means communicating, what you're saying, communicating to the people outside your field, outside academia, really, to even in some cases, talking to children, talking to people in high schools, to people not in science in general, and then so I don't know what is the best way to do this, but at least again in the U.S. there sometimes grants come with a structure that you are supposed to do some of that. So for example, there's a postdoc in my lab. It is his own thing. I think I mentioned it to someone to start. I think this guy is interested in sourdough, in the microbes in sourdough and the evolution of sourdough, because it's an interesting thing that you pass this bread to someone else and this passes to someone else so they can evolution experiment. So he uses that as a platform to communicate science to children, and he goes to a food fair in Boston, and he talks to people, and he tells them, hey, you know that this is microbes and how microbes work and so on. So there are these opportunities, but I think they're also dependent on the area. I don't know how somebody, I don't know, maybe physicists would have a harder time if they work on something very abstract. And even in a microbiologist, I have a little bit of a hard time, I have to admit, I always struggle with this when people ask me, what do you do? And really fundamentally, my questions are the ecology and evolution, how these communities form, how it's a distributed system, like I described in my first lecture, how do they self-organize? This is hard to communicate. It takes so long, and then people lose interest. So, but if you tell them about the microbiome, then immediately they're like, yes. So I have to find these shortcuts in my particular case, which I don't quite like, but it's a way to get to people, at least in my field. But I don't have a generic answer. I think it's field dependent.
So what is exactly your question?
My exact question is, what are you guys doing to try to communicate outside academia? Because I know you can speak biologists and both physics language, but I know there are schools about, yeah.
No, but the thing is that, so communicating to the broader audience is I think what most people would love to do. You want your science, you want everybody to know about your science. You want your paper to be highlighted in the New York Times. But this is the goal. It's just like
I'm not sure that's the goal. That's a mechanistic thing. Your paper gets attention in your Times.
It's not the goal, but it's like it's very rewarding if you can if you can impact society that way.
I think there's different layers to it, and I think this is an extremely interesting question. One thing, you want the research to go out. The other thing, I think, actually, the outreach done by people who had no experience in communicating science over until 10 years ago, maybe, when people started realizing that it was starting to backfire, generated a lot of anti-scientific movements because you feel entitled just because you know the results, but you don't know the process. So education to the scientific process is extremely interesting.
But we're talking about, like, for example, science journalists that have to simplify the whole story.
I think most of the science journals that you can find online, and that's one of the main problems, are actually degrading science because they're passing on information in a way that disqualifies the way that the result has been obtained, what's the real message. So really qualified science communication is very hard to find. And it's extremely delicate because you can form public opinion with that. I think, I don't have an answer to that, but what I'm saying is it's extremely complicated, and the more your subject can impact society, the more you have to study what has happened in the past and how to communicate, because if you can impact society with the communication of your science, that can go different ways. That can even backfire, right?
I think you should keep that in mind somehow, because like the funding comes from outside.
Yeah, exactly. But no, I think that.
No, I know, but.
I can mention one easy exercise. When it's not an easy exercise. A colleague and a friend of mine, he wrote a book, you can actually find it. It's called The Edge of the Sky, and his goal was to, mostly for himself, was to explain astrophysics and cosmology using the most common 1,000 words in the English language. He actually eventually used the most common 800. And it's not style. There was a specific underpinning to it. If I cannot use complicated words, I cannot use complicated concepts. So I have to take the time to myself to think about it. Now, it might seem a little bit a long path, but that forces you to keep in mind that you have to specify not the results, but the way to get there. And in my opinion, that's the most important thing.
If I can, no, I just wanted to say a thing that it seems to me that so if you work like on, I don't know, gut microbiome and health-related issues, it's easy to communicate it, right? It's easy to say, well, I mean, I'm studying this because this has health effects and it's gonna impact like the health of this. I mean, you can easily find the story. What is the challenge is to explain people that are outside academia why they give money to you to study like microbial communities like that sure, then they can impact our knowledge of the gut microbiome, but it's for sure not why we study it, right? It's very far, or even there are fields like, I don't know, pure mathematics that for sure there are gonna be impacts, right? But it's not something that you can forecast now. Huh? Yeah, exactly, like Feynman was saying, yes. Physics is like sex, right? It has a practical outcome, but it's not why you do it. That was like what Feynman was saying. I'm like just reporting what he... No, but what I think is that behind this, I mean, I think it's a challenge, and I really, personally, I don't know how to do, right? Because you can say like, well, in every country, right, there are many problems, there are no country that has infinite money, perhaps except Norway and few others, right? And you can say, well, why should you give this money to, like, I don't know, PhD?
One little thing about this. Yes. Sorry, one little thing about this. I feel like there is a disproportionate. There is an unfair thing here with biology that somehow people expected that if you do biology, it's to cure a disease or to solve a problem. In other fields, not like that. I think if you tell somebody you're studying the stars, that, oh, it's beautiful.
Actually, that's the only one. Yeah.
Okay.
So almost all fields. I think we should really look to our friends who do astronomy and cosmology, because they've succeeded. You can read an article in the newspaper about astronomy, about astrophysics, about cosmology, and it is only about why it's this remarkable thing about the universe that we discovered. You do not have the paragraph about how the instruments that they used in order to make this measurement, it turns out the things inside them are actually useful for doing something else, which is true, but they don't need to say it. Whereas in almost every other field of science, it begins by telling you about some remarkable thing. I find it actually particularly strange in neuroscience. Who isn't interested in how the brain works, right? Why do I have to explain to you? But it's almost, you can set, you could take one of those timers, right? And set the timer as you start reading, and when the timer goes off, you'll find out that they're going to cure Alzheimer's disease, right? Because if it's an article about the brain, it's supposed to get to Alzheimer's, Parkinson's, something, right? It has to get to one of the big diseases that has a devastating impact on our society. Now, that's not to say that, if you could do something about those diseases, it wouldn't be a good idea. But the path to doing it is long and complicated. And in the same way that we talk about our personal trajectories as, in retrospect, you can tell a story, that's true about every case of basic science having an impact on society. In retrospect, you can tell the story. But at the time, you couldn't predict forward which way it was going to go. So I think the question that you've asked is actually quite deep. And I think one of the things that we as a scientific community need to do is to understand that the problem of communicating science to non-scientists is, to become good at communicating science to non-scientists would be a professional activity. It's not just something we all do on the side and we don't take it. I mean, it says in the grant proposal that we were going to do this, so we show up at a high school once and we give a lecture or whatever. Maybe you give public lectures in different countries. But that it is actually a professional activity. And so in the US, for example, I would say that there's been progress on this. So for instance, when I was a kid, the thing that we all watched on TV was Carl Sagan, right? But then when I became a professional scientist, I learned that if you mention Carl Sagan's name, everybody would say, yeah, but he wasn't really that good an astronomer. Yeah, but the guy had more impact on the public appreciation of science than anybody else in his generation, right? Now, when you see people who are doing a good job of relating to the public, you don't hear that undertone of, well, yeah, but they're really not that good as scientists. So we're starting to appreciate that in the same way that, we teach, we do research, we help build institutions, we also relate to the general public, and that's another component of our professional activity that should be appreciated in its own right. But that doesn't make it easy.
So we have two more questions, first here, then there.
I would like to reflect more about this lack of scientific knowledge on the society. I believe it's because we still talking with the society like aliens. How many time have you spent going to a public school, talk about science? Do you believe that 2 hours in a week talking about science in a public school with teenagers, with kids, will make you poor? No, will make you great. So I believe we lost the connection to talk with the kids, with teenagers. This is the principal trouble. Understand? So try to put this activity on your schedule this year so you can start to change something and make something practical, okay? This is my reflection. Thank you.
Okay. So we'll go there.
Mine is also a commentary rather than a question about a little bit about scientific communication. I come from restoration ecology, so when I became a biologist, I had this huge concern about what we did in practice as scientifics. So I was very worried at the beginning about the practical effect that you can have on people's lives, and about questions about environmental justice and things like that. And the time has been passing, and what I'm thinking now is that as in the example of NASA, for example, doing outreach, we are in a moment where the most fundamental science needs to be, we shouldn't be talking to people about what does my work for. Like when we biologists keep doing that, like what you do, what it is that you do, what does it work for? And we spent a lot of time like justifying our practical implications, and now we have anti-vaxxers, and now we have a lot of like attacks directly on the most fundamental part of science. And so right now doing theory is almost a political statement where you say, no, science by itself should be taught, and should be taught for everyone, and every kid in every neighborhood. That I think we all grow as like, that kids are inherently scientists. We lose a little bit with these biases that science is hard and math is hard and only boys can do it. We lose a little bit of that passion, but what we should be trying to do, rather than communicating and justifying what we do, is like teaching more and being more democratic about it, and like fighting those kinds of biases, and like being more, like the theory is political now. That's what I say.
Thank you for the remark. So we have time either for a very short question or a closing remark from, oh, up again.
Maybe this is much more lighthearted than the previous discussion, but I wanted to ask you what kind of what knowledge from the outside field, meaning outside field, the field in which you were not training, you had not previous training in your career. What kind of knowledge was most amazing, was most interesting, most important to your career? What, for instance, for a physicist, what knowledge in biology was most important for you?
So, I guess as you were asking the question, I was starting to think, and actually the first thing that came to mind is maybe a surprising one, that for me, I took a philosophy of science course when I was an undergraduate. And I find that one of the things that did was to sort of shake up your assumptions about how science works, and this continues to be useful. I mean, it was from a guy who was very radical in his day, Paul Feyerabend. I don't know if you know the name. Wrote a famous book is Against Method, you know, this sort of trying to be critical about what it is that we're doing. I mean, it's a little bit like in other parts of philosophy. You know, we're just critical about language. You know, we're having a conversation, but there's something going on underneath. And it's sometimes useful to stop and think about the thing that's going on underneath, which is not in the words that we're actually saying to each other, but in all the assumptions that go behind them and so on. And so having, you know, had some appreciation that there are people who've thought deeply about these problems makes me a little bit more critical about how science itself proceeds. So that, I mean, there's also issues about what happens at the boundary between physics and biology, but this is also, you know, even further away.
I don't have a great answer, but I have an answer. I think that, I mean, it's not really a concept, but it's more the fact that you have exceptions, or that you will never have a theory of everything, right? You will have a theory of something, and perhaps a theory of something more, but it's like you will never encapsulate everything at every possible scales, at every possible, which I don't know if it is a biological concept, but it's something that if you deal with biology, you immediately realize. I don't know.
I think for a matter of time, if there is some closing remark that any of you want to make, a short statement or anything, now is the time. If not, maybe we should wrap up the roundtable. Thank you very much to you four first. And of course, to all of you who are the most important contributors to roundtables.
1 second, Mateo didn't ask a question.
So I think it's a good time for a closing remark by...
I have a good closing remark. Somebody always tell me there are two archetypes, there are two types of scientists, the porcupines and the foxes. Foxes are the ones that get in love with an idea and try to put everything in the same picture, while porcupines are the ones that accept the contradiction in reality. Could you classify yourself using these terms? It can be also a mix, you know, a porcupine that thinks to be a fox or a schizophrenic one that changes every day. What do you prefer?
I think Otto had a great answer for this question. So thank you, Mateo, for your great contribution. I think it's good time to start. To finish, remember that we have the public lecture in an hour.